Hi, Assalamualaikum. Let's continue with our previous discussion on L angle repair, and let's revisit what we have earlier. Is we have an L angle, and we have a thicker flange, we have a lower flange, and we have a crack. The crack is we cut off the crack, we install doubler, and then we have calculated we need to use 4 rivets in order to carry the load, and then we put a doubler over it, a doubler plate, which is not standard practice for aircraft. We just use this plate just for us to easier for us to discuss about all the analysis. And the practice we have to have an L angle doubler, so we just ignore that. So to reduce the complication, so we just consider just a plate. Okay, now if you look at from the side view, this view, what we have is we have vertical flange and we have lower flange, and we have damage somewhere here, and then we install a doubler, and we put 4 rivets, and also we have to put rivets here, at least 2, okay, to hold the filler. If you look at from the side, we have an L angle, okay, and we have a doubler, and also we have studied that the fastener is 4.8 millimeter MS 47, okay, 20470 80 rivets. Okay, now what we're looking at, we're trying to look at the function of the doubler. The function of the doubler is, this is a doubler here, doubler, and after the analysis we decided the doubler will be AISI 301, thickness 1.8 mm. Why we need this? Because we need to have a thinner doubler. If we continuing using the aluminum alloy, we will make the analysis even 2.2 mm is not sufficient to carry the load loss. Okay, the load. So what happened here, we have area loss, and area loss we are looking at earlier we have made the analysis. The load loss is 11923 Newton. So the area here no longer can carry the load, so the load should be carried by the doubler. So we have 11923 here, and then transfer to the doubler 11923, and transfer 11923, and transfer down to the portion of the doubler. Okay, transfer down to the lower flange. The good lower flange is 11923. So by the time you move the load from here, move up to the doubler, okay, the load here 11923 loss due to the damage area, transfer through the doubler and come down to the good horizontal flange. The analogy, the easiest for me to explain, okay, imagine this is a channel full of water, okay, then the water move freely, no problem. So as we cut the damage, cut the flow, okay, cut the flow, so the water cannot move freely anymore. So what we do, we put a diversion, detour, okay, the detour, we dig another channel ditto, this is channel, cut because of the damage, and then we open up an opening. Okay, opening. So the flow can go through here, go through here, and go through here, and go through here, flow fully here, and come down to the channel, until you got complete flow. So we can imagine this is 11923 and transfer across 11923, and then here, okay, we divide by 4, 11923 divided by 4 is 2980. So 2980 across, 2980 across, 2980 across, 2980 across the channel. We got 11923 here. Transfer down to the first one is 2980, 2980, the second one 2980 and 2980. So that is how we can make an analogy. Okay, let's look at let's explore this in a big detail. Try to look at as a mechanical joint. So what we have here is we have okay, let's blow it up. V1, and we have here is the flange here. Okay, say we have a cut. Okay, because of damage we cut, we make a doubler. And then we have 4 fastener. 1, 2, 3, 4. 1, 2, 3. Extend this. 4. So this is doubler. This is the doubler which we have studied. We have did analysis SISI 301, 1.8 millimeter thickness. Okay, now whatever loss we have studied, which is 11923. So we have loss due to damage here. So you need to carry this from this lower flange. Cannot go through because it's already damaged, and then you have transfer back to 1923. Otherwise we're not going to get into equilibrium. So we have, in doing this analysis, we should earlier we talked about static stress analysis, and we also make assumption that the load carried by the fasteners average of the total load. So the each fastener will carry out equal load. So if you divide by 4, each will carry 2980. So each fastener will carry 2980, 2980, 2980, 2980. So you got 2980, 2980, 2980, 2980, and you total up, you got 11923. So that is what we have assumed. Actually, what happened is it's not always the case. Okay, basically, if you measure, so the stress or the load transfer will be in this manner. I mean the highest peak point at the beginning and the highest peak point at the end. So this is how the load transfer. However, like everything else, just like also we learn about the stress, we always work on average stress. So we also work on average for us as engineer to be able to make a decision, because the differences in looking at the variation of the rivet strength will not mean much for this analysis. Okay, now we have this 11980. Okay, just to draw here, and then the first will be transferred to the rivet here is 2980. Then equilibrium move up to 980. Symbol arrow. Oh sorry, it's reverse. Okay, so here is 1123. So first 2980. 2980 will be acting on the 2980, acting on this portion of fastener, lower portion. Then it transfer up 2980. The remaining goes here, then we got 2980. So we have also here, we have 2980. 2980 here. Then everything, every time you load this fastener, it transfer up. 2980. Transfer up. 2980. Transfer up. Okay, because it's this one 2980. So everything is transferred up here. You can see the arrow on this direction. So mean that you have transferred 11923 to this plate here, this section here. Okay, so as you transfer here, we have another same 11923. When they see this, first it will come to the here 2980, and then we'll continue on to the next one 2980, and here is 2980, and here is 2980. So as you load in this direction, so the reaction is 2980. We have reaction on this side 2980. We have reaction here 2980. We have reaction here is direction is this direction 2980. Then everything total up for this portion, and move the whole transfer as 11923. Okay, here. So we got 11923 here, we got 11923 here, mean the whole load now fully transferred. So that is how the rivet works, and how you transfer the load, and that's how we need the doubler to transfer the load across from the good flange. The mesh can't transfer anything, and then you put a doubler over it, and then the transfer to that, and then you transfer down back to the good flange.